reversible reaction, A reacting with B to give what? C plus what? C plus D. Okay? If you balance this, what? Let us look at this. If this A has coefficient of A after you have balanced it, this B is having B after you have balanced this, and this capital letter C is having what? C after you have balanced it, and this D is having what? Small letter D after you have what? After you have balanced it. Okay? If you look at this and agree with me that this is a reversible reaction, meaning that this is going like this and this is going like this. That this is going forward reaction and this is what? Backward reaction. Are you getting it now? So that means you can split this reaction into what? Into two. Are you getting it now? For forward reaction, this is what will happen. A plus B to give what? C plus D. This is for forward reaction. What if it is not backward reaction? This one will not be the reactant because it's not going from here. You now have what? C plus D to give what? A plus B. This is now small letter A. This is now small letter B. So this will not be the reactant. This will not be the reactant. For forward, this will be the reactant. For backward, this will not be the reactant. Are you getting it now? Now, for forward, I hope you are jotting. Now let's now consider for forward reaction. If you are considering forward reaction, how you write rate law? At times we call it rate law. But as far as this place is concerned, we are using what? Law of mass action to write the what? The rate constant. So if you want to, to write the rate equation. So now, from here now, rate, according to law of mass action, okay, is directly proportional to what? To the product of the reactant. This is reactant, this is reactant. The product of the reactant A with what? With reactant B. According to law of mass action, which says that rate of chemical reaction, which is denoted with what? R, is directly proportional to the what? Product of the what? Of the reactant. Are you getting it now? Raised to power of their what? Coefficient. What's the coefficient of A? A, small letter A. What is the coefficient of B? Small letter B. Are you getting it now? Now, this R is for what? Forward reaction. At the end of the day, okay, RF, okay, is not equal to this, that proportional sign will change to what? K. We now call it what? KF for forward. Then you have what? A raised by what? A and what? B raised by what? B. This one is now for what? For forward reaction. It's now what? For forward reaction. Now, let's now consider for backward reaction. Let's consider if it is backward reaction. So the rate for backward reaction is equal to, okay, is directly proportional to what? Product of the what? Of the reactant. The reactant are this and this. If you are considering backward reaction, this will now be what? D. This is small letter C and this is small letter D. Now, rate for backward reaction is now equal to what? K. K for what? Backward reaction. Okay? C raised by what? C and D raised by what? D. This is for what? For backward reaction. For backward reaction. Okay? I made you to understand that at equilibrium, the rate of forward reaction is equal to what? The rate of what? Backward reaction. That is, RF is equal to what? RB. Are you getting it now? What is RF? I can clean this over. Okay? RF is equal to what? RB. Okay? At what? At equilibrium. What is RF that we got the other time? We have it to be what? KF into bracket what? A raised by A and B raised by B for forward. For backward, it will be what? KB, C raised by C and D raised by what? Raised by D. Are we getting it now? Now, Let's first divide both sides by A raised to power A, then B raised to power B, then this one. A raised to power A and B raised to power B. This one will cancel this one. And then you have what? Kf to be equal to what? Kb, C raised to power C, D raised to power D, divided by what? A raised to power A and B raised to power B. Are you getting this now? At the same time, you still now do divide both sides by what? Kb. Divide both sides by what? Kb. Are you getting it down? Are you getting it down? Kb will cancel Kb. At the end of the day, you have Kf all over what? Kb is now equal to what? C raised to power C, then D raised to power D, divided by what? A raised to power A, and this is what? B raised to power what? B raised to power B. Are you getting it down? Now, you see this K, all these K that I'm talking about, we call them rate constant. What do I call it? Rate constant. This is rate constant for forward reaction, and this is rate constant for what? For backward reaction. And this is what? Rate constant for backward reaction. Now, you see this Kf over Kb is still the same thing as what? K, we call it equilibrium constant. What do I call it? Equilibrium constant. The ratio of Kf, that is the ratio of rate constant for forward reaction to rate constant for backward reaction, is equal to what? Equilibrium constant. Equilibrium constant. Now, equilibrium constant that we are not talking about, okay, is represented with what? With K. The equilibrium constant is represented with what? With K. Now you see this K, it can be in terms of concentration, and at the same time it can be in terms of what? Partial pressure. It can be in what? So now if it is in terms of concentration, because we are considering concentration since back, because this square bracket, I made it to understand, is called what? Concentration. So that means you call it Kc. If you are dealing with concentration, okay, the equilibrium constant in terms of what? Concentration, you call it Kc. But if it is equilibrium constant in terms of what? Partial, you call it what? Kp. So, but still we are dealing with what? Kc, then we have what? It will have what? C raised to power C and what? D raised to power D, divided by what? A raised to power A, and this is B raised to power what? Raised to power B. This is now what? Equilibrium constant in terms of concentration. Equilibrium constant in terms of concentration. Partial pressure. What it will be is what? You now call it Kp. You call it what? Kp, which is now equal to, now instead of concentration, what will you call it? P. That's the symbol for partial pressure. P what? Pc. Raised to power its coefficient. What's the coefficient? C. Multiplied by P what? Pd. Raised to power what? Its coefficient. Divided by what? Pa. Raised to power what? Its coefficient. Multiplied by what? Pb. Raised to power what? Its coefficient. This is now what? The equilibrium constant in terms of what? In terms of partial pressure. Equilibrium constant in terms of concentration is equal to what? Concentration of what? Of the product all over what? Concentration of the what? Of the reactant. That is the meaning. So, okay, let's take for example, you have nitrogen plus what? Hydrogen to give NH what? NH3. Now, the first thing you have to do, if you are given any reaction, you make sure that it is what? Balanced. You balance it first. Okay, if you are balancing it, you have what here? You have 2 here, you have 3 here. Is it balanced now? Okay. So if all of them are now in gaseous states, you are now to write the what? The equilibrium constant. The equilibrium constant in terms of concentration. Okay, I made you to understand that it is what? Product concentration all over what? Reactant concentration. Which is now what? What is your product? Your product is what? NH3. NH3 raised to power what? 2. Divided by concentration of what? M2 raised to power what? 1. Right? Multiplied by H2 raised to power what? 3. This thing that you have written is called what? Equilibrium constant in terms of it will be is that Kp will now be equal to what? It is still product, but we now call it what? P ammonia, which is NH3 raised to power what? 2. Are we looking up? Divided by what? P nitrogen. That one is raised to power 1, or you may not write it. Multiplied by what? P what? P hydrogen raised to power what? 3. So this is now what? Equilibrium constant in terms of what? In terms of fashion.